In this video, we will cover the review exercise 3 at the end of tutorial 3 on pages 250 through 253 in the text. I highly recommend that you take sufficient time to first look over the drawing, make any necessary calculations, and read the instructions that follow, as these are the guidelines I will use to grade the assignment. You'll notice that some of the general functions you learned in tutorial 3 will apply to this assignment, while others will not. However, we will find solutions to those obstacles. The first thing that does apply is that we are going to draw the stock into the part drawing like we did in tutorial 3. Open a fresh MasterCam slate, and we'll start by creating a rectangle that depicts the stock we're going to cut the wrench out of. The X value is 6 and the Y value is negative 2.5 because we're working in the lower right quadrant, so Y is negative. We hit enter. There's our phantom rectangle, and I will place it at the 0, 0 origin. We can mouse wheel this down or do a fit, mouse wheel it. Now I am looking at this part and I see a series of circles and lines. I'll start by putting in some of the circles. The first one being the jaw of this wrench. Create circle center point, shortcut. The radius of this interior jaw is 0.75. Enter, get my phantom circle. Now I will go to fast point and put the location of it in. The center point of this circle is at X 1.25, comma, and the Y is at negative 1.25. Enter, and that circle is placed. It looks good so far. I'm going to accept it, but stay in the operation because I want to do some more circles. I'm going to go back to the tail end of the part, put those two circles in. One of them is a radius of 0.625. Enter, get my phantom circle. Go up to fast point. The location of this circle is 4 inches more than the center point of the first one, and that calculates to 5.25 inches, comma, and the same location in terms of the y-axis, negative 1.25. That's basically the center line. Enter, and that hole is placed. I've got another one with a diameter of 750, diameter 0.75, enter. Okay, see, I didn't hit apply, so it overwrote it. Sometimes that happens, sometimes it doesn't. I'm going to go ahead and keep that one, and I'm going to have to go back and redo my radius 625 circle. Hit apply. Go back to radius 0.625, enter. Snap to center point, and there I've got my two circles at the tail. This looks like a really good time to put the all-brown shape in, so I'll go to create rectangular shapes, pick the all-brown. The width of this slot calculates to 1.75 plus 0.25 at one end plus 0.25 for the radiuses at the other end. Enter, that's 2.250. The width is 1/2 inch, so 0.5, enter. And here's my phantom all-brown. Now I've got to put the location in. that is first determined by which one of these anchor buttons I choose to pick. Now obviously I'm going to go horizontally along the center line, as I've been doing everything so far. And I'm going to pick the left end of it because I have a print dimension of 2.375. So I go up to my fast point. In X I'm at 2.375 according to the print, comma, and the Y I'm the same old -1.25 inches to center. Enter, and there's my oblong shape. Looking good so far. At this point I may go ahead and put in some parallel lines to that slot and work my way to the left. Create line parallel. Mathematically these are offset by 1/4 inch, 0.25. Enter. I'm going to lock it because I'm going to make 2 of these. Select a line according to this prompt. Select a line. There's one of those. I'm going to select apply it just in case. Select a line and offset that. So those parallel lines look good. Parallel lines, I'm sorry. I'm going to accept it. I'm going to go ahead and also work this part of the drawing through trim and extend. Here's a shortcut to the trim and extend. By using the single button, it's telling me I want to make this line go to this circle and this line go to this circle. Then I can go up and activate divide. I'm staying in the function still. Switch to divide, and that will just take that out. See, when you hover it tells you what it's going to do ahead of time. That's really nice. And now our part's starting to take shape. We'll accept that. I'm going to put some more lines in for that jaw. Create line endpoint. Here I can just snap to the tangent of this circle. However, I want to make sure my lines are perfectly horizontal, so I'm going to activate that button. Snap to tangent, just horizontal out past the part. Snap to tangent, horizontal out past the part. And there's part of my jaw. I'm going to accept that. I'm going to go back to parallel lines. These ones calculate to 0.375 or 3/8. I've already got it locked. Select a line and offset direction. Select a line, offset direction. Those look really good. I'm going to accept them. I've got one more parallel line I can put in, and that is the ends of the jaw lines. That amount is 1/8 or 0.125. And select a line, this vertical line here, offset to the right, and that puts in the ends of those square jaws. Accept that, and now we've got some trimming to do. Go to my scissors. The divide's on. I'll go ahead and use that here. Take that out and take that out. Now I'll go to trim 2 entities, and what that is saying is it will make a corner for you. So you say I want to trim this line to here, and it'll go ahead and take the rest of the corner out. I want to trim this line to here, this line to here, and this line, when I go to this line, it should take them both out. Yes. Now we've got the remainder of the part to do, and if you look closely at your drawing, you'll see a radius of 1.125, and you'll sort of see it phantom all the way through the part. In other words, they're giving us a hint that we may want to put the entire circle in for now. So I'm going to create circle, make sure I'm checked out of everything. Create circle center point with a radius of 1.125. Enter. Here's my phantom. I've already got a center point, so I'll just snap it to that. And that looks like it's in the right place because it matches up with everything. Accept it and check out at the same time. We'll do the trim divide. Take that out. Then we'll go to our single trim one entity. Say trim this arc to this line. Trim this arc to this line. Looking good. Check out. Now all we have to do is put the angular lines in, and you'll notice the print doesn't even give us any angular lines. And that's because we're just going to do the intersection point tangent to that circle we just put in. So you go to line, endpoint, snap to the end of this line. I forgot to activate tangent, but you can still do it in the middle of your operation, because here we have vertical and horizontal. This time we want tangent, and it'll go tangent to that line. Snap to the end of this line, tangent to that arc, and there they are. So that's the way to use tangent without any angles. Accept that and check out. We've got a trim now again. Hit the scissors, use the divide function. It may take 2 steps because it's hitting something else. Very good, accept that. The last thing we need to do is, if you look at the lower right of your dimensions on the print, it says there's 4 fillet radiuses of 1/4 of an inch. Here's my fillet shortcut. 1/4 inch is already in there. I'm going to lock it. And I'm just going to say fillet. Here it says fillet, select an entity and another entity. Start again. Select an entity and another entity. Again, select an entity and another entity. And number 4. Looking good. Accept and check out. And there's our geometry. Now we can start to set up a machine and start cutting the part. So having selected our default mill and creating this machine group, I take a look at tool settings. I set everything the same as we've been doing all along, except I'm going to change this program number to 6 because this is your 6th job. It's not really that important. The stock setup, we're using the top view. It's a rectangular piece of stock that we want. We're going to ask for a wireframe display, that our origin be set at 0, 0, 0 in the upper left hand corner of the stock. And our stock thickness in terms of the Y direction is 2.5 inches. We don't use negatives here because we're talking about stock thicknesses. It's 6 inches in the X and it's 0.625 in the Z. So that all looks good. Now we can start machining our part. The directions on page 252 ask that we remove the material in the slot first. And if you look at these pictures, the slot is blind. If you look at the print, the section AA view also shows that the slot is blind, but there's a discrepancy with the isometric view that's on that print. It shows a through slot. We need it to be blind. And it's at a depth of 0.1875. So we go to Tool Paths, Circle Paths, Slot Mill. Don't worry about the NC name right now, it's going to change later anyway. We're set on chain. Pick this chain. It lit up very nicely. It's closed and solid. Closed meaning there's no exit, which would be the red arrow. I'm going to switch it to clockwise direction and check out of that. Now I work my tree view list for this operation. Slot mill, The tool is a 1/4 inch flat end mill. I've got one here because I practiced, so I don't need to go through the tool library. Here I want to say machine slot, so that'll show up in my program accordingly. Jumping to cut parameters. These all look good, except I don't need to leave any stock anywhere because this is a acceptable machining process. This is usually used when we're doing high-speed milling because it's kind of choppy and it doesn't leave a good finish. So rough and finish, we'll leave those the way they are. Depth cuts, we want to take off 0.1 hundred at a time in layers. Let's go ahead and put a finish cut in the floor of this, one of them, at 0.02 since this slot is so shallow, and we'll keep the tool down. There is no breakthrough, we're going to disable that. Linking parameters is where we set our depth. Everything else should be basically this pattern. And our depth is negative 0.1875. That looks good. Let's go ahead and backplot it. Fit, isometric, and play. We're inside the slot, so that's good news, and we are below it, and that's good news. See how we ramp in as we go, 100 thousandths at a time. And there's our finish cut as well. We zoom in on this. 2 rough cuts and a finished cut. Exit out of that. Our next operation is to circle mill the 3/4 inch hole. It says 1/4 inch hole, but it's a 3/4 inch hole using a 1/4 inch drill. So we go to tool paths, circle path, circle mill, pick an entity, not a center point. I want to pick this entity. It lit up, it's picked. Check it. Circle mill, tool. Again, it's the 1/4 inch. Machine, hole, cut parameters. We don't need to leave any stock. This is an acceptable operation, meaning the finish will be fine. You won't have to go back and rework it. You'll see that going forward when we do that. We are instructed to enable roughing, so I will. We'll do a finish cut on the sides because we're going to break through. One finish cut of 20 thousandths. Those look good. Depth cuts we will enable. We'll take 100 each time, each layer. We won't need a finish cut because we're going all the way down through. I mean, it's going to be cut off when we flip it and face the part. So in a sense, we're using a breakthrough because we have a 5/8 piece of stock and a 1/2 inch part, so we'll have an 1/8 inch remaining. That's 0.125, so instead of breaking through on 100, I'm just going to break through on 50 just to make sure we're good. Set our depths and linking parameters, and this is negative 0.5. Keep that. This operation selected. This is the one we want to backplot. Those settings were fine, and we went to the right depth. We spiraled in. Excellent. Next, we want to rough the outside profile using 2D high-speed dynamic core mill. Toolpaths. 2D high-speed dynamic core. Chain. We want to pick this box and reverse it to clockwise. This is why we use geometry to represent the stock, because you can't just pick stock. And when we're hogging a lot of stock out of there, we want to set limits. And this is what we're doing right here. I'm going to select that, and then I'm going to go to multiple machining regions, and I'm going to pick Avoidance Region. And it says to pick a chain. This is the chain. I want to reverse that. And see, my whole wrench is the avoidance region. So it's going to take between the wrench and this boundary. And it's going to do it in high speed machining, which is a relatively new concept. It has to do with extremely high RPMs, and it just kind of pecks at the stock and allows chips to be removed and not a lot of flexing. It's very stable, and but it doesn't do a great finish. So that's where your leaving stock business sort of comes in. And you can do it any time, but this is where you want to do it most frequently. The tool they ask us to use is the 1/2-inch flat end mill. And here we're going to rough the outside. Cut parameters are very different for every operation, but especially these high-speed ones. Refer to the settings you used in tutorial 3 when we first tried this. Approach distance lights up when we highlight. It's down here. It's how we're going to approach the stock. We used 0.5. That's the thickness of our end mill, or the diameter of our end mill, so that makes sense. It's pretty efficient. This gap size, we can set a distance, or we can just go off the tool diameter. You see, it wants to know gaps from this island and gaps from this island out, and we basically made it 5 times the diameter of the tool, so it's 5 full strokes away. Optimizing the cut order within pocket, you'll see that come into play. I'll point that out when we're verifying, but it just has to do with it not jumping around and staying where it needs to be until it needs to move on. I'll show you when we're doing that. The book instructs us to leave stock on the wall only. I'm going to just leave 20. We don't need to leave any on the floors. We don't care about the finish of the floor because enter. We're going to flip the part over and face all that off anyway. We don't use depth cuts on here. We take the whole thing in one shot. Entry motion, helix, and those parameters are fine. We don't use breakthrough on this. And now we set our depth. Our depth is -0.5 because it's the full thickness of the part. We're not using breakthrough because we don't want to break through all of that. We'll use breakthrough when we do the finished contour, and you'll see that play out as well. Take that. This is selected. BackPlot. That's sort of that efficient thing where it just tries to stay in one spot and finish the job before it moves around. So I'm going to go to parameters. Cut parameters is on. This optimized cut order within pocket. That's what makes the cutter stay and do as much work as possible without moving, as we saw on the BackPlot. Our last operation before we go to another setup is to finish the outside profile using contour and a 1/2 inch flat end mill. So we go to Toolpaths, Contour, pick the chain, same chain as we just roughed to, and we left stock on. Looks good, close, pick the chain, contour, the tool is the 1/2 inch, finish, contour, outside. Go to our cut parameters. Everything looks good here. We're not going to leave any stock anywhere. We don't need to use depth cuts here. We can do this all in one depth. Our lead in, lead out, we can just shrink our radiuses a little more if we want to be efficient. Our approach is 90 degrees. That looks good. We are going to use a little bit of breakthrough on here just for insurance, to make sure that the whole finished contour reaches the face off. Breakthrough, but let's drop it to 50 just like we did before, because we only have 125 stock to work with. 0.05, enter. No multi-passes or tabs. Linking parameters, it's still -5 because we put a breakthrough in, so we'll go actually 50 more. -0.5, enter. So far so good. This is selected. Go to BackPlot. And run it. The path is on the outside. The approach and the exit look good. I'm going to keep that. I'm going to select everything. Now they're all lit up. Check, 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 check. Go to verify. Fit. Isometric. Here's my 4 operations. 1, 2. This is the big dynamic core mill that's hogging all that stock out, and then our finished contour is the green. Slow it down some and run it. There's our blind pocket, our through hole, even though they're not through because we have stock that needs to come off. Speed it up for part of this. See how it's working optimally? Start slowing it down now. At full depth it's working. Again, this is the high speed machining. Okay, that last contour was quick, but it was really just one pass around to finish without using high speed machining. So if we look, our slot is blind, our hole is much deeper, and probably when you face it, it's going to clean off. Wheeling closer, I can see that I didn't use breakthrough on the hog part, the dynamic core milling, but I did use it on the finished contour mill, just to make sure. So I'm beyond the 500 mark here. This should all hog off. It just really disappear. This is going to fall off when I do my thickness to here. Does that make sense? So that looks good. Check out of that. And now we are going to do our second setup, flip the part and face all that excess material off and be holding a wrench. Now all we have left to do in terms of operations is to create a new setup so that we can flip the part and face off the rest of the stock. Before I did that, I followed the instructions in your tutorial 3 from the book and clicked on this twice, changed the name to setup 1, then I right clicked on it and edited the select operations, changed the NC file name, it needs to be 1. You'll see that show up here, setup 1 on each operation. Also our program number right here, if you hover, that's our 6th job. I then right-clicked on the machine groups, and created a new toolpath group by clicking that. That's down here. And my insert operation arrow is subsequent to that new setup. So I'm ready to set up the operation, except for the fact that I need to approach it from a different view, in a new perspective. So I'm going to go down to the lower right to this World Coordinate System button. Select View Manager. I'm going to create a new view by selecting Geometry. So I'm going to pick something in the X and the Y on this, and it's going to give me a variety of perspectives and views. Basically, I need everything the same, except I need to change my Z-axis. I literally need to reverse it. The red means negative and the green means positive. And obviously these are incorrect because right now up here in my Cartesian coordinate, I am X positive and Y negative. So I need to try another view. I'm going to alternate and middle mouse this back over here. The next view offers me, first thing I need to do is look at the Z. I need a Z going in the opposite direction that it is now. That one looks pretty good. Z down, pointing down. Y positive is that direction, X negative is that direction. I'm going to accept that view and give it a name. Call it bottom view. Say OK. And there it is. In order to activate it, because right now the top view is still active, this is just an additional one, I need to hit the equal sign, and that'll bring my construction plane and my tool plane and my active icon into view. Now I'll enable the origin. In the X it's 0. In the Y it's 0, and then the Z, my origin is now at positive 0.625. I will check that. And that looks very good. See, I'm working on the other side of it now. Okay, so from here now we can insert our operation. We can go to Toolpath, Face, pick the chain. It's still this chain. I'm going to reverse it. I've just moved the Z-axis and come from the other side. That looks good. It's a face. The tool is I need a 2-inch face mill. It suggested me one. I'll take it. Face the bottom of the part. There's my tool, my cut parameters. I want to go with the zigzag. Move between cuts and high-speed loops to save a little time. We're not going to leave any stock anywhere. Face mill's actually pretty nice. No depth cuts. I'm just going to hog it. There's not much left anyway because we frequently broke through 50 thousandths of our 1/8 inch. So, and then our depth is -0.125. Well, let's try it. BackPlot. Fit and isometric. Slow it down a little bit and run the job. Let's zigzag in the x-axis. And that makes sense. And it looks really good because here's the rest of my stock. Here's my actual keeper part. Looking good. Let's go ahead and pick everything, all the operations. Verify them. Fit and isometric. It's showing it to me in that plane now because that's my active plane. But what I can do is go back to my world coordinate system. I don't care if you do this or not when you turn it in, but what I can do is activate this view. Check it. Do my isometric. Select all. Verify. Slow everything down. And hit play. We can pause at any time. There's our blind slot. There's our through hole, even though it's not through yet. Now we're doing the dynamic core milling. All in one depth. There's no depth cuts on this, which would be layers. We allowed it to optimize, which it's doing. This is the high-speed milling that is relatively new and only capable in modern machines. It sort of pecks at the material, or kind of like a piranha. It's really active and at extremely high speed and a lot of movement. Climb and conventional do play a part in this, but they're really pretty irrelevant. But you can take a lot more stock out a lot faster using this high-speed machining. Now it's working its optimizing capability that we checked. It's not moving around and wasting any time moving back and forth or anything. I'm tempted to speed this up, but I really want to capture the fact that we left stock on here. I'm going to go and pivot it while it's still running. We left stock to do with the contour mill. See if I go real close. We left that stocked, and we're going to go back and contour mill that later. I can fit an isometric while it's moving. But the stock is there. And we didn't do a breakthrough on the dynamic core mill because we're just going to face the rest of that material off the bottom. But we did do a breakthrough on the contour finish cut so that we make sure we're finished all the way down. I think we broke through 50 thousandths of the remaining 125. And then, as you saw, and look how slow we were running it. As you saw, it did the one finish cut contour, which is a better finish than the 2D high speed, and then it faced it off at the bottom. But that's exactly what we want. We need to close this window, I'm sorry. You can turn this into me in either the top or the bottom view that we created. and either, I don't care which one of these views. Basically, I'm going to check your geometry and all the parameters within your operations. So, good luck.